Okay, in this little live stream, I am going to try to create a chromatic aberration filter. So right now I currently have, well, let's start with this actually. We're gonna start with a basic, um, oh my God, yeah, let's just verify that I'm human here. And then we're gonna start with this little thing. And I'm gonna get rid of the last one. So just don't think that one's going anywhere. I'm sorry, closing it. All right, so we've got this, and this is just a shader that I wrote as like a template for any of the other ray marching um, art shaders that I want to do. And last night I was looking at trying to make something like a chromatic aberration effect, so that would require a buffer. And then I put everything in the buffer and return it there. And then in this channel, I would call everything from buffer A, and I make that the color. So instead of having all that stuff happening, well, we'll just say vector 4 will take all the data back from texture, I channel, whoops, I channel 0, UV, and then we're gonna add like just the first 3 elements of data, which is the RGB, and let's just make this just a regular coordinate function or coordinate transformation there from 0 to 1. Okay, so let's get the buffer A back. Boom. All right, we're good. So all this other stuff, we can delete it. We don't need it. We have it in buffer A. And I'm just gonna fork this. Okay, so now we're working on a new one, and I'm just gonna call it chromatic ab. I don't know. Let's save it. Okay, so chromatic aberration. So the first thing that I try is we're gonna make a function called chroma, and then it's gonna take in the UV, and then in this function, it's going to do this a bunch of times to get the result. But I'm just gonna take the 3, and it's gonna be color, and then we're gonna return the final color. So we could basically do that and then send that here, or literally send this right to the end here. Chroma, UV, get rid of this. It should be the same thing. What are we missing? Cannot convert. Yes, so we're just gonna take RGB. All right, so that's our basic function that doesn't really do anything yet, but so the basic chromatic aberration idea that some people will do is, first of all, they'll just call like color with nothing first, and then they'll like separate it into its components, and then just so then you'll split it up with R, right, G, B, and then for each of those you will shift it. So like on one side, you'll shift it like a little bit to one side. Let's see. I don't know, I guess we'll just be like, and then the other side, we'll shift it the other way. So maybe you can't see that yet. Let's do this. So you see how that works? So that's like the most basic chromatic aberration shader that you can make. And the problem with this is that it's literally just like it's clear, it's obvious what it's doing. It's like it's just drawing like 3 cubes. Like it's drawing 3 of the picture that are just slightly spaced apart, and it just looks like, it doesn't look realistic, that's for sure. And it looks cheap. It looks fake. So we want to do something way cooler than that. And so where can we start with that? So like so there's 2 main issues with this. One is that we're using the exact same, like we're shifting the exact same amount, like anywhere in the screen. If we're talking about the blue, we're shifting it one way. If we're talking about red, we're shifting it the other way. And for green, we're keeping it the same. We're shifting it the exact same amount everywhere for each of the elements. So what we want to do is we want to not do that because a chromatic aberration is an effect that comes from an actual camera, and the way the camera works is that's an effect that's happening from the refraction of the lens, of like light coming through the lens. And so you're seeing the effect of light scattering from the lens through the lens in different directions, based on the like what wavelength the light is. So um, so it's basically like a sort of blur effect is what we're doing. So we want to blur it, and so there's a bunch of different ways to blur things. Like the most one of the most popular blurring algorithms is Gaussian blur, and there are ways to do Gaussian blur in shaders. Um, and then there's of course depth of field, which is like a blur that blurs things more based on the depth or where you are in the world. And you can do a Gaussian depth of field blur or a bokeh depth of field blur. But so what we want to do is just some kind of like, we can basically not fake it, but just find an algorithm that will kind of blur things in a way that like it's satisfying to us. It's like that's a real blur. um so blurring is like taking weighted samples in some area and then combining them together, and making sure that we divide by the sum of the weights so that the resulting color is still going to be like a color between 0 and 1 on each element, if that makes sense. So let's see, let's do like a really basic blur and just to kind of like get things working. So we want a for loop with float I equals 0, and then if I is less, no, how about this? So we're gonna do a directional, just like only horizontal blur. So we're gonna go from -5 to +5, and then we're gonna go I plus 1. All right, so this is the most basic blur we can do. So we're not even gonna have different components here. We're just gonna have all of it. RGB, and then RGB, and we're going to move. So another good thing to have is let's know what the size of a pixel is based on like our current like resolution, and we can do that by saying x is going to equal to 1 over the I resolution and xy. So that is a vector 2 that tells us the resolution on an x and y. So we can go like a vector 2 of like pix x and then nothing. So we're going to be basically shifting what pixel we're sampling from. So this is sampling the buffer at whatever the pixel location is in UV coordinates, so from in a scale of 0 to 1, but then we're going to shift it by the I resolution, which is also 0 to 1, which is what we want. And then we're going to add or multiply by the scale, and the scaling factor is going to be this I value, so that we're going to start by like -5 pixels, so 5 pixels to one way, and then 5 pixels to the other way. And I've got to change my, hold on. This is supposed to be flipped horizontally. Yes, my window is over there, not over there. Okay, anyways, yeah, so once we do that, we should see a horizontal blur. It didn't work. Okay, but it didn't work because we need to do this. We need to sum. This is like a sum of color. It's not actually the color yet. We're gonna sum it, so we're gonna add all of that together. Now, what happens if we add a whole bunch of versions of this together? It's really white. It's really white because we've added a whole bunch of versions of the color together without, and so it's like now it's way more than 0 to 1, which is the range of colors that we see on the screen. It's like way higher. So we have to now, like, we have to add all of these weights together, because those are the weights that we multiplied. No, sorry. The weights that we multiply by right now, it's just this. We're going to get to the actual weights in a second. So now we can just say, like, we went -5 to +5. So I'm guessing that's like 11. So if we divide by 11, we should be back. Yeah. So now we have like a horizontal blur. right? Can you see that? Let's go full screen. Does that look blurry to you? It should. Otherwise, you can make it more blurry, like go like 8. There, okay? Now do you see what I'm saying? There's a horizontal blur right now, and it's super blurry, all right? So that's the basic blur. And now another thing we can do is we can blur, but we can add more, we could add the blur more based on the distance. So like right now, when we're 5 pixels away on the left and the right, we're still adding just like one regular unit of that color to the final image. But now we want to weight it differently. We want to be like, the further we are out, the less of that color we want to use in the final image. So something like, I don't know, the weight can be like 1 over the I, and also like absolute of I, because we want it to be positive no matter what. So now it's like we're gonna have a weight that's when, well, we don't want to have 0 because we're gonna divide by 0 if we do that. Or we can add 1. We can add 1. Can we add 1? That's weird, right? We could add 1. Um, that's confusing because I want it to be less. Um, no, we have to add 1 to I. No, because then we're always gonna have something being 0. I mean, the cheapest way is like we'll just be like max of I and 1, so it'll never be not 1. Like it'll always be, and that should be the abs sort. Abs here, right? So now I'm just kind of like I'm just trying random stuff. So the absolute value, so it's 5 to 5, and then the 1, so absolute, so it's going to be 5, 4, 3, 2, 1, and then another 1, and then another 1, and then 2, 3, 4, 5. And then we're going to divide all that into 1, so that we're going to get something from 1 over 5 to 1 over 1, and then back up to 1 over 5. And then we're going to make that the weighting factor. So we multiply that by the weight. So every time we add it, we're adding a weighted value. And then now we can be like, what does that look like? That's still a little bit much here. But it's less, but it's still like not weighted. Like we still have to divide something to get the right value. So what we can do now is we can add, we can have a sum of weights. Sum of weights is going to be 0. And then every time we do one of these, we're going to go sum of weights plus equals W. And then we divide the sum by the sum of weights at the end. Now we got this. So now we have a blur, and it's still not so super visible, but now we have a blur, but it's like, it's clearly like, I don't know, it's better. So why don't we just go to 10 then? Maybe we'll see more, because now we're gonna take 10 samples on each side. Is that not blurring, or like what's going on? Why doesn't it look like it's blurring? Okay, 20. There's definitely a blur happening. Do you see that though? It's like a really weird, faint kind of blur, but it just looks kind of like ghosty. Um, we could also change like we did this before. We could do that. Maybe just like this. Yeah. So now we have a blur that does that instead. And hold on. Let me go like 10. 10. It's still pretty clear, right? Like the difference. There's a blur, but it doesn't stay the same amount. Like as you move out, the blur gets more faint. So it's like a ghosty blur. Yes, I like it. Um, so that's how we would do blurring with like weight. But what we want to do now is we want to have weights. So now instead of this though, we want to have like a radial blur instead of just, so, and we're moving, so you remember what we're talking about. We're trying to make a chromatic aberration filter that's going to change the color as we move out, and I guess along a different direction for each color. I don't even know how we're going to get to that, to be honest. Like, I don't know how we're going to get to that from this, but we're going to try. But so let's start with making, actually, let's start with that now then. So now we have that. So basically, let's go like out to either side with the different colors and see if what that does. So we'll just take these colors and we'll split them up now. So now we're gonna go R, G, B, right? R, G, B. All right, so now we're gonna do this thing where we change things. Um, and we can leave green in the middle with not doing anything. Basically multiply by 0. And then on one side we can add it, where on the other side we're subtracting it. Look at this. So doesn't that already look better? Like that's already a much neater chromatic aberration because it doesn't look like it's just, like it's more, yeah, it's cooler. But then again, I would still want to be like, now I want to go like 5 or 8 just to take advantage of like what we have here. Like it's pretty cool. See, look at that. Doesn't that already look much better than what we had before? So now we're going to take it to the next level and we're actually going to make a circular blur. And so I'm thinking like, so there's a bunch of different ways to make like circle, like samples around a circle. We can either just like go like a bunch of different rings, so like a smaller ring, a larger ring, and a larger ring, or we can go like a spiral, or we can use Poisson disk sampling, which is like you have a set of samples, you know all the locations are such that you're not too close to any other samples for each sample, and then it's all in like a circle. But I kind of want to just go with the one in the middle, which is like a spiral, because that's kind of easy to like conceptualize and probably write the code for it too. And then and yeah, it feels like it's going to be less work because it's only one for loop instead of two, um, or instead of like making a whole other thing. So we're going to take this, I'm just going to tab it out. Sorry, this too. Tab it all out here. So we're going to do 10. So what we're going to need now is we're going to need to make a vector that points in some direction and it's a certain length. And then as it moves around, that length has to get longer and the angle has to change. So let's start by like, how many loops around do we want to do? And that's how many times of pi we want to go around the circle. Okay, so let's say we're going to start with 0. And then, and yeah, and we're going to have a rotation function. By the way, I'm just going back and like, I don't know. So we're going to make a rotation. So we're going to have a rotation function that takes in an angle that we're going to calculate. And then it's going to have it's going to do the rotation. So S equals sine of A and C equals cos of A. Can do that, right? And then what we're going to return is a matrix 2 that goes, oh my god, I'm going to say something really insensitive, but like, just bear with me. Cool. Okay, I'm gonna do the nice way. Cool, comma, ninjas, negative for ninjas, stay socially conscious. That's how I've remembered this matrix thing for years. Cool ninjas stay socially conscious, except instead of ninjas, I say something else. All right, so let's get back to it. So it returns a value now, and we're gonna use that. So we're gonna say 0, and then while it's less than, like how many, oh, I gotta figure out how to write a spiral. I don't know. Now I'm starting to think I'd rather do the dumber version. Let's do the dumber version. So we're going in a circle. So we know we're going to, oh wait. So we need to know how many points, like, so like if we do a circle, just one circle, we're gonna need to know how many of these points in a circle we want to have. and like at each level. So like let's say we want 10 points, then we need to get like pi. So like pi is equals 3.141592. And then the actual segment, like the angle, one segment of the pie, of the slice, is going to be pi divided by whatever the number is. So like we have to have a number and like 10. So then we're going to divide the segments by, divide pi. No, it's 2 pi, sorry. 2 times around the circle. I mean, the full length of the circle. Okay, so divide that by n, and that will give us the number of, like, that will give us like a segment length. So then we can go like, while this is less than pi 2, then you're not going to add just 1, you're going to add the segment length. So now we're adding the segment length to I as we go from 0 to 2 pi around the circle. And that's like, basically the I is now the angle. And so now we have to have like a vector. So let's start with a vector. I don't know. V is going to equal 1. So the vector is now just like 1 unit, but times pixel. So okay, so the vector should be pixel times whatever we were using. Pixel x times 4. Yeah, and you know what? See, the tricky thing is like this is not going to take into account aspect ratio. So I hope it still looks okay. All right, but we're gonna take this vector, we're gonna make it that, and then we're gonna go in here, and then for each time through, we're gonna get an angle using A10. Wait, no, we're gonna get the vector. We're gonna take the vector, we're gonna multiply by the rotation of the angle, rotation by the angle, and get the new vector. So on the first one, when we have 0, we put 0 into the rotation function, we come out with a matrix that doesn't rotate it at all. All right, and then we're going to get that vector, and then we're going to use that vector. Instead of using this, now we're going to use the vector. But wait, so are we going like vector and then negative vector? Or are we going like vector and then like some other area? Anyways, we're going to do the dumbest way. I really like this version though. Like I want to save it. Because if all else fails, I still have that. Man, my laptop is getting hot. Okay, we got this. Let's just pretend we're just going to do vector. And then negative vector. Or like positive vector, negative vector. And we're just going to use that. And then this is going to have nothing. So for the red and blue channels, we're kind of basically going like this around the circle to make our samples. All right, so every time we go, but we shouldn't be rotating. Oh, I get it. Why would we rotate? Why would we rotate by more angle? Like, why would we rotate by a larger angle every time? Unless we create a new one. If every time we, okay, so every time we do this, we should rotate by the same, like, by segment each time. Because if we rotate by angle and then we add to the angle and rotate by angle again, we're going to make like larger and larger steps. So we're going to rotate by segment, which is 10. We're going to do that 10 times because this is going to take 10 times to do that. Which means we don't even need to do this. We can just be like n. And then I++. Right? Because we're using segment. Because like we know that segment is a certain number of the angle, like a certain number of slices, and that number is the number that we're gonna step through by. So we're always gonna get the right answer with segment. So we can just use segment and that. So now W, what's gonna happen to the weights now? Well, the weights will be the same, because the length is the same, and the length is what is creating the blur. So the length is 1, so we're adding 1 to this the weight each time, the sum of the weights each time, and then everything else should be the same. Let's see what it looks like. Okay, I'm seeing some chromatic aberration, not a lot. Let's increase this. And the thing about this is like, all right, at least don't be okay. So it's different, right? I think it's I think it's different. Um, but there's no weighting and there's only one level, so there's not too much that could happen here. So what if we do like an internal, no, like okay, so what if we want to have weights now, instead of doing this here, we're just gonna have like a bunch of layers and we're gonna do that each time. But then I think like the segment should change as we go up, or no. That's okay. All right, so um we're gonna do this again. The I, but we'll call it J now. Because for every time through, instead of just making one sample, we're gonna make J samples for float J equals 0, J less than, and then I don't know how far out do we want to go, like 5. Okay, so now we got to think about like operation, or think about how much calculations we want to be doing here. We have 10 around this way. I say like not more than 5 out, and that's already a lot of accessing the texture here. And J++, boom. All right, so we got that. So that's doing J, and then we're doing, so this calculation, we have to fix this because it should be, so first of all, this should be 1, and then this should be less than or equal to 5, and then we want to have that. So now it goes from 1, so when we go, the further we go out, the less the weight is going to be added. And once we're closer, once we're at the in part, then the weight's going to be more. And we're adding the weights, and then we're summing the weights after. What does this do? What happens? J. Okay. So this should do this. Hold on. Ah, yes, we have to actually apply the change in scale here. So instead of this, let's see. Yeah, I don't know. Because we can multiply, we can keep this the way it is right now. And then once we get here, we multiply it to scale by J, right? What happened? Let's see. So by J, which is just 1 to 5. Um, Okay, so then we can add like a basic amount of length here, like that, or like 10. I don't know. Is that better? Is that better than what we had before? It feels like it's kind of the same, but it is going like around now, which is maybe why it's kind of creating more like of a bubble. But damn, that's not much better. Not sure what I was expecting, but not that. The sum of the weights works well. Um, hmm. Yeah, I'm not sure what to do here. Should I should I take a peek at someone else's answer and see if I learned something? Because I feel like I could learn something. So this right now, the weights are doing that. So they're definitely getting more thin as we get out, because it feels like the horizontal blur looked better. Like that looked more like a real blur. This one just kind of looks kind of dumb. And I don't know why. Maybe because we're all the way around, we're at some point. Yeah, I don't know. RGB, RGB. The green doesn't move at all. What could be the issue here? Yeah, so I'm gonna just take a quick peek at someone else's, see if I can learn something here. I know who to check out. Uh, there's someone who used to do this stuff all the time. I want to see if their version will teach me something. But yeah, so there's that. There's a Poisson sampling. There's a spiral sampling. What did he do? What did they do? They did one level. They normalized. Okay, so first of all, the scale for the blur isn't just like a. What did they do? So it's a radial blur. They get the chromatic aberration. So that yeah, they do the same thing as me where they keep G as like just itself. They don't change G at all. No weighting or anything. Um, which is surprising actually. They don't weight. They just divide by steps at the end. They have the target, which is like the UV plus the offset is done separately. But then the chromatic aberration, so there's an offset. Oh, right. Yeah, then they have the offset, which is normalized of UVN, which is what is UVN? Oh, so they're offsetting by, okay, so they're using the UVs, like the base, like the UV that goes from negative 0.5 to 0.5 on the X and Y, like that type of thing. They're using that, they're normalizing it. Um, what? And then scaling it by steps. I get what they're doing. Oh, that's so cool. Okay, so the other way, so what someone else is doing right now, hold on, is that it though? And then they scale it, which and then scale changes as they move up, and then steps. So it's scale, which is increasing, divided by steps, which is increasing, and they're just adding it, and then they're just dividing by steps at the end. I don't know. That's weird. And then Chrome ab is pow of length of UV. What? So that's what? Is that like how much we're moving out? This is weird because it's like the blur is happening on every single pixel, like with its own kind of weighting. So it's blurring, okay, so it's blurring out from the middle then, instead of like it's literally, but then there's steps though. And it's normalized though. So it's not doing that. So what their algorithm is doing is it's saying like no matter where you are, your blur is happening based on your current like where you are along like around the screen. You're blurring based on where you are around the screen. What we're doing is we're saying wherever we are, we're going all around the screen. So that's like very different because our blur is going to be based on like yeah, that's very different. So let me see if I can try their version. And I might as well give credit to who I got this idea from. This guy Jaco, this person Jaco uses a lot of like blur. So so how can I show you the code? So that's the code that I'm like learning from. But I just want to get the gist of it and then try to write it myself, even if it's not totally correct. Kind of want to just see what I can do here and like explore. So another chroma, and this time instead of having that double for loop, it's going to be a single for loop. And instead of, whoops, so, and it's going to be n because we're doing a bunch of steps along whatever the gradient, whatever the direction is. But instead of like assigning all of the directions, which is what I was doing, they're just like the direction is whatever the UV was. Whatever the UV direction was, that's the direction for this pixel. And then we're just going to move around on that pixel. So basically, I don't know, we could just take in another one of these. We need the UV like this. So then it's kind of like, can we make another UV? Yeah, okay, they did it the cheap way. I mean, they did it not the cheap way, but you know, let's just pass in another one. We'll call it like UST, I guess. And then we're gonna just be like, you know, so U vector 2 ST. All right, so now we got the ST. What in the world? Okay, we got to get rid of all these, but let's just figure out what we're gonna do. So now we got the ST is gonna be the one that does this, and then and then and then divide by I resolution Y. So that's actually fixes the problem I was talking about before with the aspect ratio. Yeah, that's fixed here. So it's always going to be circles. So we got that ST, and now instead of having vector, it's going to be normalized ST. Normalized, sorry. Just talking, I'm typing what I'm saying, but so it's a normalized of ST. And then when we got the ST, now we're going to do the steps in here so that we have like a bunch of different steps. And for each step, we're going to increase the ST. But they also, like what they did was like a sort of a decay because they're multiplying by 0.91 each time. So they're kind of decaying it on their own. But if we don't do that, then we get to use the weights as they're supposed to be used with no, and that's the difference is going to be that there's no exponential fall off, but we can create an exponential fall off ourselves. And if we do that properly, then we can apply that to the weights properly, and that should be better. So let's try that. So instead of this, we don't need to rotate anything. The weights, we're gonna make, so the weights, I feel like that's right for the weights because it's, as we move away, the weight should be less. Okay, so that's the basic one. And so it's W, and then we're adding W, and then instead of V, well, V is already V, but then V, and then step, so like I. So then now it's like a certain number of steps, but then W. Okay, so then we need to have like dist is going to be I, which we can change I to be like some other thing instead of just I. But like I. Whoa, I haven't seen anything like that before. Okay, so the n is 10. We're making 10 steps. For each step, we're doing, it's not abs anymore. It's like, it's always, like we just do like this. No, it's always going to be positive, and then we can be like I, and then that should be okay. But what's going on? We got normalized. Oh, right. So we're normalized. We're doing V as like the length of 1, and that's way too like big, right? It should be 1, but then divided by P by X, PX X, I guess. So now we have that. And yeah. And the only thing is that now that we normalize it, we're kind of getting back we're kind of ruining the aspect ratio a bit, or no? I guess not. I guess we could just use, well, we could use a shorter vector, but then is that helping us? But now, anyway, so now let's just increase everything. That's interesting, right? Whoops. That's different, right? That's like, even just 2 or 3, like, yeah. Oh man, that is fancy. Look at that. So there's clearly blur happening because of the weighting, but it's like going out. Like it's going out in the direction of the pixel. That's a lot better. Wow. And then what they did was they have like an exponential fall off. And if I can just like, can I just cobble together like graph toy? Hold on. So what if I try to cobble together my own like exponential function? Hold on. Like what is that? So we'll get rid of all of these and we'll just use this and we'll just make it like X. So right now the fall off is linear because we're going, well, it's like, wait a second. If we're divided, oh wait. So if we have 1 divided by x, which is our n, which is the steps that we're taking, and then we make that our weight, then it's not a linear fall off, right? That's not linear. The distance though is linear. So we have to decide, do we want the distance to be linear and do we want the fall off to be linear? Because we can change either one of those things. What do they do? Scale, and then scale is, so they're going like scale. Let's see. Can I even show this code? I feel like I'm like breaking the rules by showing that code. Let's just uh but yeah, so I feel like it's not linear already. But so the decay, it's going like this as we move from the 1, because hold on. Hold on a second. Wait, what number is that? Oh, it's just going up to infinity right there. Ah, it's going up to infinity at 0. So anything less than 1 is like starting to go up to infinity. But so like let's look at, we need to have another one on the screen so we can see where 1 was. 1 is there, right? So we are like here. Sorry, whoops. We're everything after 1. So we go from 1 to 10. Does it show? It shows on the bottom. Oh, you're not seeing it. Hold on. So we go from 1 all the way up to 10. And that's like here, I guess. So we're going from here to here. And you see the fall off is doing that. That's like very, like it just really trails off. So what if I wanted it to be not like that? Then I could just, I don't know, can I just use the power function and fix it? Does that make it better or worse? I feel like it's worse. So if you do something like that, but that's only changing the stuff that's before, like that's only affecting the things that were lower than 1 or smaller than 1. We don't want to do that. What's another thing we can do? We can use the X function, which I don't even know. I don't know. So what do we want when we're like, this already looks good. I don't know what I'm complaining about. Like I would want to have more steps. So instead of 10, like make it 20. I don't know. Like that's already effing awesome, man. I guess it's only like, why is it that some sides of it don't actually move around? Like, do you know what I mean? Like it's like kind of like this and then like that. That's the only thing that I was like, hey, why are we doing it like that? But that's not going to be fixed by changing the scale. And I don't know, I like this. So the reason why I wanted to do chromatic aberration in the first place is because I wanted to have like some sort of like, I wanted to have pulsing music or pulsing anything to affect the chromatic aberration. And so we can do that now because dist, um, no, sorry, because of the weight. Wait, the weight being, no, the distance, yeah, because of the distance. If the distance is I right now, like if the distance was 1, like there would be like almost nothing. But the distance is I now, which goes up to 20, so that's like a lot. But we could also go like distance divided by 2 so that we get like more within like a smaller area, more samples, which can also look better. It's like more like crisp, like more, I don't know, more solid. But Yeah, there needs to be a way to say like nothing. I guess that would be zero. Like if we had, like if we just multiplied by zero, then there would be nothing. And it would just be like that. So now let's go and grab our microphone input, allow this time. All right, so my microphone is now showing up here, and we're gonna take that, we're gonna try to smooth the output, like smooth the yeah, the output of it, because right now it's picking up everything. There's like a rumbling happening all the time. So if we look at this output, it looks like there's like 20 of these columns, and like by like the second or third one, or like the third, fourth one, like we're getting like the biggest peak of like my voice. So I want to take that. So I want to go like, what is that? Like that would be like 5%. So this is 50, so 3 columns out of 20 columns. 4 columns out of 20 would be like 2 out of 10, which would be like 20%. So this is like 20, 25%. No, no, oh my God. Yeah, 2 out of, I don't know, something like that. So something low. Okay, so we're gonna go to Chroma, and we're gonna get the um the audio in just one channel. Texture I channel 1, and then we're gonna grab a specific portion of it. This is all out of 0 to 1. So like we could just basically take pixel and use that here. Pixel X, and then we want a certain amount of it. We want to have like pixel X, which is like times, I don't know. Um, well, it's basically just going to be like 0.1, 0.05, okay, and then 0, and then it's going to be the red channel. So we're going to take that and we're going to add that to this, basically multiply by this. So now when I talk more, there's more, like it shows up more, I think. Yeah. But maybe I'm looking at the wrong area. Let's go like here. No, okay, let's go like here, there, even less. How about here? Okay, I guess something like that. Let's put it into the color and see where we got the biggest peaks from me talking. Let's just play around with it and see what happens. So we'll just go, oof, I don't want to do this, but frag color equals vector 4. Okay, so yeah, that's pretty big, but let's move around. Now we to see where specifically, because I feel like I'm just kind of doing it in like the dumbest way possible right now. But how about this? How about this? How about that? 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 It's never as bright as it was right around here. Hello? How about like that? Hello? How about like, whoops. How about this? How about this? I don't know. I guess that's fine. I wish I could just be like, where is it? Okay, how about this? I'll be like, just to see if there's anything that I'm missing. I'm gonna do that. So I'm just curious. Is there something that I'm missing? 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 Is there something that I'm... Okay, nothing crazy different than what we've been getting. So, right? Like that. Hello, hello. Hello, hello. Hello, hello. Hello, hello. There, we're gonna take this, and then we're gonna jack it up. So we're gonna take that, and then we're gonna go like way more. Like, let's go. So first we want to clap. We want to smooth it so that nothing. Oh, I'm not even on in the chat. So, all right. So what I don't want is to have all of that rumbling. I want it to like go like 0 when there's nothing and then high when there's something. So I'm gonna try to do pow of some amount. Whoops. Okay. And pow. Yeah, so that gets rid of pretty much everything. And then if we want to get it back, then we gotta be like this. Yeah, there you go. You see that? So when I'm talking, it's just suddenly big. When I'm not talking, it's gone completely. I don't know. How about like that? No. It should be even more like this. But no. But like that? Hello? Yeah. And then make this higher. So now it's like this. Hello? How's it going? That's what I wanted this whole entire time. Hello? So that's it. That's all I wanted to do. Something like this. So like there's constantly, I mean, it might be too much, to be honest, but I also actually really would rather have even more happening, like some sort of glitch effect or something. But yeah, so we got this, and then I want to, anytime I make it, like I want this to be my new template so that there's like something to watch, you know? So the next time I'm making a video about anything else, no matter what, you're gonna see this happening. Um, the only other thing I might add is like, what if it was like the distance changes what you get? So like, what if we put the distance in here? Like t that over far. So now we have some value from 0 to 1 that represents the distance. And then if we take this value, um, like, and just like add in, so let's see. Yeah, we'll just get the texture one time, but we'll get specifically the D, A, no distance. So we got the D everywhere. And then what if we use that to modulate this? Like, what would that do? Oh, look at that. So now it's like kind of like weird because of the way the distance field works, but you can see like as we move further away, there's like ripples of like you're seeing the distance field now. What if I divide it? I felt like that would be, oh, that's interesting. What if I just, well, yeah, I don't know. But yeah, you see what I mean? If I didn't want to have those crazy lines, what could I do? Smooth step? I don't know. Um, 0 to 1. That again. Could I smooth step it? Yeah, okay. So then there's this. So now it's kind of like, oh, but that's weird. Where's the green? What happened to all the green, you guys? Um, but yeah. No, really though, where's the green? That's weird. Is the green just gone? It's that's very confusing. Hold on. Okay, so there's green now. But when I do this, then there's no green. It must be not moving when I'm at the box. That must be what's happening. Okay, anyways, we're not doing that. We got it, we got it, we got it. You guys, we're good. You can change this, you can make it, what do you call it? You can change the maximum distance. You can make it like less if you want it, so there's still like something, but it's not crazy. You go like that, and yeah, it's up to you. It's a cool effect there. And I'm just gonna upload this so that people can see that this is a cool thing that you can do. And also, I guess it's like we've explored a whole bunch of different chromatic aberration effect algorithms, and we've come up with the best one by, I don't know, basically ripping off somebody else's code. Except I like to think that, like, you know, I did it myself. Like, I definitely stole the main idea from someone else, but then like I didn't just like copy and paste the code. I understood it, and then I wrote it, and I had an aha moment of like, wow, that's so cool. And I think that's kind of like when you can feel like comfortable taking something that someone else made and like making it your own. And of course, I also didn't go the whole way. I kind of still did my own thing with it. And yeah, I like that. So that's my video. I'm gonna upload that, and I'll see you in the next one.